Alright, so this video will be showing some examples for each of the sections in checkpoint 1 for kinetics and equilibrium. So let's get started. So a reminder, our K's for equilibrium is equal to our products over our reactants. So for the given equation where I have nitrogen gas plus oxygen gas to give me nitrogen monoxide, to write the K expression, K is going to be equal to, we're going to put brackets around for concentration. That's what the C stands for, is concentration. So I'm going to put NO because it's a product. And I'm going to square that. Where that square came from is this 2 right here. That is where this 2 comes from right here. And then I have no more products, so I'm going to put that over. I'm going to put N2. Okay, there's a 1 here, so I'm just going to leave that blank for a 1. And then my concentration of O2. And again, there's a 1 there, so I'm going to put a 1 there on the top. And that's it. So let's do that again for this one down here. So I've got K is equal to, right, my KC, K for concentration, KC for concentration, is equal to, I'm going to put products over reactants. So I've got my SiCl4, and again, nothing there, so I could just leave my, there's no exponent, times my hydrogen gas. And again, I'm going to square that. That 2 right there comes from that 2 is over, right, my SiH4, okay, which I've put nothing on. And then I've got my Cl2, and I'm going to square that. Again, that 2 is coming from there. So that is how you would write the expressions. Expressions do not include solids or liquids. So anything that is a gas or aqueous is what you would write in here. If it has an S or an L after it, you do not put it in this expression. Alright, so now we've got some manipulation of our C. Of our KC. So this part right here actually goes over here, so we'll rewrite that in a minute. So if we change anything on our equation, so this is our normal balanced equation, and this is the K for that at equilibrium. So if I were to say, for example, in this expression here, right, what I've done is I have taken this whole thing and multiplied it by 1/2. And in doing so, right, that gave me this equation. And so because I multiplied this all by 1/2, all I have to do is take my Kc from before, right, which is equal to the 0.043. What I'm going to do with that as my new K, right, K naught, is going to become, is going to be that 0.043 raised to the 1/2 power. Okay, so anytime I multiply, so if I take my reaction, right, reaction, and I multiply it by n, right, what I'm going to do to my K, what happens to my K is now going to be K raised to the n, like we see here. So for 2a, what we did is we multiplied this whole expression by 1/2. So what I did to find my new K naught is I just took my original K and I raised it to the 1/2 power. Okay, now for 2c, we've noticed that we are now, I have flipped my reaction. I have flipped this reaction. So when you flip the reaction, what's going to happen to your K is you're going to do 1 over the K. right? So just by flipping, so we flipped this and we've multiplied it by a half. So for my new k, my k naught, right, is now going to become that it's going to be 1 over 0.043 raised to the 1/2. Or you could write that as 0.043 raised to the negative 1/2. Okay, so again, if you multiply your reaction by a factor of n, your k value is just going to be k raised to the n. If you flip your reaction, so that means you make your products your reactants, your reactants your products, so we flip it, it's going to become 1 over that original k value. Right. So calculating our concentration, I picked 3C because you have to actually calculate your moles for molarity, right? So mole, right, is not the same as a capital M. Okay, this right here is moles per liter. So here, right, I can write my K expression. K is equal to, it's going to be NO squared times BR 2 over NO BR squared. Okay, so to calculate for my KC, I'm going to need to find the concentrations for NOBR, BR2, and NOBR. So they give me my moles and they give me how many liters that they're in. So my concentration of NO is equal to that 0.175. That's moles divided by 3.5 liters. Okay, my concentration of BR2 is equal to 2.18 moles per 3.5 liters, and that concentration of my NOBR is equal to that 1.35 over 3.5 liters. Okay, so now I've got my new concentrations. So concentration of NO is equal to BR2 and then I've got my concentration of NOBR is equal. So if I do my calculations in my calculator, so I have that 0.175 divided by 3.5, so concentration here is 0.05 molar. Okay, 2.15 divided by 3.5, I've got 0.623 molar. And then I got 1.35 divided by 3.5, and I've got my 0.386 molar. Okay, so now all I have to do is just plug these values. I'm going to take these values here, and I'm going to plug them into here. So what I get now is, I've got K is now equal to 0.05 squared times 0.6323 over 0.386 squared. And when I do this math, I end up with K is equal to 0.0105. Remember, K does not have any units. It is unitless. Okay. So please pay attention to if they give you moles versus molar, which is going to be a big capital M. Okay. Big capital M, you don't have to do this extra math here. You just have to plug in your values into here. If they give you moles and then they give you liters, you're going to have to calculate your moles per liter first before you plug them in. Because this C here stands for concentration. Okay. Example for 4, you're doing the same things what we just did before, except for now you're using pressures instead of concentrations, right? Kp. P is for pressure. Okay, so we still have to come up with our constant, so it's going to be N2 squared times O2 all over N2O squared. Plug in my pressures, so I actually don't have to put the brackets, I could just put parentheses. Okay, so this becomes K is equal to my 0.00012 squared times 0.00053 all over 0.31 squared. So when I plug that into my calculator, I end up with K is equal to I end up with 7.94 times 10 to the negative 11th. Okay, final set of examples is which way is this going to shift if it's not already in equilibrium. So they say if we're at equilibrium or Kp and Kc is equal to 2,800. So I got to determine if this is an equilibrium, if it is not, which direction it's going to go. So when we calculate our new K's, if K is greater than, like much greater than 1, then it's going to go to the products. If our K is really, really, really small, so smaller than 1, it's going to go to reactants. So down here we're going to calculate out. So we've got K is equal to H2 times I2 all over HI squared. Okay, so I'm going to need to calculate, right? They give me moles here and they give me liters, so I'm going to have to calculate out my molarity. So I have my molarity of HI. I've got my molarity of H2, and I've got my molarity of I2, right? And these are equal to 0.043 over 1.25. I've got 3.3 over 1.25. And I've got 2.1 over 1.25, which will give me new numbers. Let's figure out what those are. Okay, now all we have to do is plug these values in, and I end up with 2.64 times 1.68 all over 0.0344 squared. And when I put this into my calculator, I end up with a K of 3,747 0.8, right? Is equal to my K. So because K, right, is larger than here, then that means we're going to be shifting towards the product. Right, because my K is larger than 1, so it's going to shift towards the product. Right, if this value ended up being lower than this 280, then it's going to shift towards the reactants. Okay, and that's how you would solve for 5 and 6 on checkpoint 1. I hope this helps clarify some questions. Please email me or send me a message via Remind to let me know if you have any other questions.